Okay, so for this problem, I'm going to be doing my first homework problem from my mathematical physics class, or math methods, whatever you decide to call it. And it's considering this function, f of x equals 1 minus 4 over L squared times quantity x minus L over 2 squared, where x is between 0 and L. And so first it wants us to sketch this function, so we're going to do that. So let's just write it out real quick. So that f of x equals 1 minus 4 over L squared times x minus L over 2, this quantity squared. And then x is between 0 and L. And yeah, so if we just draw this really quick, we have, this is 0 and this is L, so this is our domain that we're looking at. So first we'll just notice that when x is 0, what do we get? So if x is 0, this term is gone. This is L squared over 4. L squared over 4 times 4 over L squared is 1. 1 minus 1 is 0. So it's 0 here. Okay. What about when it's equal to L? So L minus L2 is L over 2. Okay, so 1 minus half of 1 is still 1 half. And that gives us the same thing, because L over 2 squared is L squared over 4. And we get the same thing if you look up here. Okay. So that's also 0. Now, in the middle, we get L over 2. And this thing is, you know, looks like a parabola to me, right? Because we have the x squared term. So it's probably going to have a point at L over 2, right? In the middle. And we can just verify that. You know, if you put L over 2 in there, L over 2 minus L over 2 is 0. And that makes it 1, right? It's right here. 1. So, oh, I'm so sorry. Alright, so we sketch it. So that's A. Wants us to sketch it. B, it says it's asking us which orthonormal basis would be used based on what we've done so far. Explain why. Okay, so since it's a string, you know, and we can use this same basis. This is what we were using in class, in pi x over L. And there's a couple reasons for this. It's because it's an orthonormal function. It satisfies when this phi, or whatever you want to call it, or we'll call it y sub n because that's what we were calling it in class. Why does it do that? It doesn't respond at first. Okay. Yeah, so this is our y sub n. This is like this function, the basis that we're going to use, and it expands any square integrable function that vanishes at the endpoints. So that's why this is a good one to use. It's also, you know, it's a wave, right? So it has like this parabolic behavior almost within a certain limited domain, and so this is what we're going to use. Okay. Now we need to find the coefficients. This is C. And our coefficients, we find them by, you have this idea where you have like a to b, right, y, and times some phi, and this is equal to, you know, a to b. Oh, what happened there? Why did it jump? What did I do? I don't know, like, I don't understand this technology sometimes. Anyway, I'm just going to rewrite it. Let's go like that. So we have this full expression, y sub n, an infinite sum of a n this is going to be ym, okay, and then yn dx, and that is equal to a to b ym star phi. Okay? And so then if you just write it in bracket notation, ym times some phi, this is equal infinite sum am times ym this is sort of our starting point. So you get so then you get this an, and it equals yn with your whatever phi, and this is our function, so I'm just going to write f x here. Okay. And so what is that? That is explicitly written as, we have our constant 2 over L out, because we have this that we're going to bring in. This is our y sub n. And then we're going 0 to L sine in pi. Normally it'd be 0 to infinity, right? But we're going throughout our entire domain, which is 0 to L, so there's no point to do infinity here. And that times 1 minus 4 over L squared is our function, x minus L over 2 squared dx. And the rest of this is just doing calculus. So buckle up, because there's a lot to do here. Okay, so let's keep it fresh and interesting. Let's change color to this one. So a sub n equals y sub n with whatever this function we're going to call phi, and that is this up top. So we end up having two different, I'm going to go ahead and split it up now. So we have 2 over L, 0 to L, sine in pi x over L, minus, then we have, okay, we're going to have square root of 2 over L times 4 over L squared, integral 0 to L of x minus L over 2 squared, oh, sorry, I'm totally wrong here, one second, I forgot our sine term. Then we have our sine term, sine of n pi x over L times x minus L over 2 squared dx. Alright, so we got these two integrals here, and our first one, so we're going to label this one 1. Okay, and then this one's going to be 2. Alright, so number 1 is pretty easy to solve. Okay, it's just sine, and then the integral of sine is negative cosine. So we get negative square root of 2 over L of cosine, oh, oops, we also need this term, sorry, L over n pi, cosine of, evaluated, cosine of, sloppy right now, cosine n pi x over L, evaluated at L and 0. And that's it for the first one. So we'll go ahead and solve that. So when x is L, then we get n pi. So n pi, if it's 1 pi, it's negative 1. If it's 2 pi, it's positive 1, right? So that means this whole expression is positive when n is odd. Okay? And the whole expression is negative when n is even, okay? So just keep that in mind, but we're going to move on. Now if it's 0, if x is 0, cosine of 0 is 1. So we just have a minus 1. So let's write this again. We have minus square root 2 over L. L over n pi. Then we can do this. We do negative 1 to the n, because now this is positive. Because we took the negative out, so now we have negative 1 to the n. So let's make sure this works. So if n is 1, cosine is negative 1, right? N is 2, cosine is positive 1. There we go. So we got that correct. So that's how we write that. And then minus 1. But we need the brackets here. And this is our first solution to, yeah, that's our first integral. Alright, so we're just going to keep that in our things here. Hold it aside for now, and we're going to go into our second integral. Let's just rewrite it really quick. So we get this minus square root of 2 over L, 4 over L squared. 0 to L sine n pi x n over L times x minus L squared. X minus L over 2 squared. Okay, x minus L over 2 squared dx. Alright, so what do we do about this? Well, this one we have to do integration by parts, which everyone knows and loves. So our u, just remember, those who don't remember, uv minus integral v du, right? uv minus v du. Okay, so our u is going to be x minus L over 2 squared, which is going to make our du what? 2 x minus L over 2 times the derivative of the inside, which is just dx. There you go. And that makes our dv, keep in mind, our dv is going to be sine n pi x over L dx, don't forget that. Which makes our dv the antiderivative, right? Oh, sorry, not dv, just v. So our v is going to be the antiderivative of that, which is L over n pi negative L over n pi cosine n pi x over L dx. Nope, not dx. There's no dx here. Okay. Yeah, good. So we have this now to just write it all out. Now remember, don't forget your factors in front 2 over L. I always write them because I don't want to forget them. Okay. So this is multiplied by uv, which is x minus L over 2 squared v times minus L over n pi cosine n pi x over L minus, oh, don't forget, you integrated it, so you have to have limits, or limits of integration, L 0, okay, then minus the negative integral, so plus integral 0 to L v, which is L over n pi, we'll put over here, cosine n pi x over L du times 2, so we'll take the 2 out, we'll put it over here, 2x minus L over 2 dx. Okay. Now, we've got this third integral here. So let's solve this one. And then we'll dive into the next one. So this one, we have limits of integration L and 0. So when cosine is L, we get 1 again, right? So we get the same thing. We get this minus 1 to the n, minus 1, times all that stuff. Okay. But when this is L, we get L squared over 4. So when this is 0, we get L squared over 4 again. So we get twice L squared over 4. L squared over 4. Let's just write it all out, okay? So we get L over 2 squared stuff with cosine times, okay, well, times minus L over n pi times minus, oops, it's minus 1 to the n minus 1, because we're going to get another L squared over 2 again. Okay, you see that? And so these two are going to be factors in the next one as well. It's going to be the same. This part does not change. So then we just explicitly solve this L cubed minus L cubed over 2n pi times 4 over L squared, so this goes to 1, and the 4 makes it turn into a 2, so we get positive square root 2 over L, L 2 times 2L over n pi. Now, did I do that correctly? Yeah, I did. That's all correct. Times minus 1 to the n minus 1. Okay. Now this is our next, this is the answer to number 2. 2.5, I should say. Because here's, now we have a number 3. We'll change colors again so we can see them easily. Okay, so number 3, we got 2. First, you can't forget this. You still have this. I know it looks like I disconnected it, and I kind of did, so I'll reconnect it. These factors go on to this one as well. So we get this negative. You always have to carry this over. Negative square root of 2 over L. Nope, not 4. L, not 4. L times 4 over L squared times 2L over n pi. Okay. Now we can, I'll rewrite it. Oh, why not? L cosine n pi x over L x minus L over 2. And I'm not going to break this up into 2. Since I have to do integration by parts anyway, I'm just going to do that right away. We have our u. Should technically say u prime. Okay, do that. So the math people don't yell at me. Okay, I'm a physics person, not a math person. Okay, u prime is going to be x minus L over 2. Which makes my du prime just what, 1 dx. So finally, we have that, and then our dv equals cosine n pi x over L dx, and that makes our v L over n pi sine, positive sine, of n pi x over L. Great. And I just write that down. We have u times v x minus L over 2 times L over n pi. Don't forget we have these factors here. All of this is guaranteed. Okay, I'm just going to put a little star there so you know not to forget that. Okay, L over pi sine n pi x over L, and evaluated at L and 0 minus L over n pi du 0 to L sine n pi x over L dx. There we go. We finally get something easy to solve. Let's evaluate this side first. So we get when x is equal to L, we get n pi. That is always 0. And sine of 0 is always 0. So we can get rid of this, which is nice. So that goes away. This goes to 0 always. So then we just evaluate. We bring down all our factors here. Well, what do we have? We have a minus square root of 2 over L. What do we have? 4 over L squared. And 2L over n pi. Times, oh, this is going to turn into a plus, times L over n pi, 0 to L sine n pi x over L dx, and that is going to give us, let's just simplify this. So we got 2 L's down here, we got 2 L's up here, we got m squared pi squared times 8. So we got 8 over n squared pi squared times square root of 2 over L times L over n pi. This is going to turn negative, and we get cosine n pi x over L evaluated at 0 and L. Alright, so this is, we get this whole shebang all over again. With the negative 1 to the n, right, minus 1 times all this stuff. Alright, so this is our final piece of the puzzle. Now we just need to put it all together. And that is our answer to the integral. So we get this negative 1 to the n minus 1. We get that a couple of times. 1, 2, do we get it 3 times? We get it 3 times. Okay. So let's just, yeah, that's all of them, right? So let's kind of factor that out, and I'm just going to put that in front. Maybe not the best way to do it, but it's just the way that I want to do it. And then we have a negative square root 2 over L over n pi. Let's write that first. Root of 2 over L over n pi. Okay, minus or plus plus square root of 2, 2 over L, and pi again? No. Yeah, plus the same thing. Plus square root of 2 over L, L over n pi. Look at that. Those are going to cancel, right? Okay, minus 8 over n squared pi squared, square root of 2 over L, L over n pi. So these two cancel, which is nice. And then we get this. So we get your answer is negative 8 over n squared pi squared, square root of 2 over L, L over n pi. Oh, so we can actually just make this 8L, and make this a cubed. So rewrite that real quick. Minus 8L over n cubed pi cubed, square root of 2 over L, times minus 1 to the n minus 1. Okay. So that's our answer to the entire integral. Whew. Which is, what is that again? This is our a sub n, right? Okay, so that is the whole kit caboodle there. Now we just need to multiply that by our original thing, our original yn, right? Because we want an yn. And what is that? That is our y of n, remember, is square root of 2 over L sine n pi x over L. And, yeah. And, yeah, so we'll multiply these together. And these are going to combine. We'll get a 2 over L. So we get a n y m equals minus 16 over n cubed pi cubed sine of, almost, yeah, no, this works. Sine of n pi x over L times minus 1 to the n minus 1. And that is our a and y sub n. Now the next part of this problem, it wants us to plot it, which I'm not going to do here. I don't have the software to show that to you. But yeah, so that would be the following thing, is just to take this equation and then plot it in whatever you want, MATLAB or Python, and then allow n to get very large, and it should look like our original graph up here. So it should look similar to this, is what essentially we're doing. Because the whole point of this is to take a Fourier series and, yeah, add them all together. So to approximate a function, which is what we're doing. All right, well, thank you very much.